This is our video for lesson 4.5, analyzing lines of best fit. So again, we're still using these same equations. Okay, we still need to know how to calculate slope, put something in point slope form or slope intercept form, and determine which is the appropriate form. Today we're going to be looking at two new ideas. One is a residual, and then the other one is a correlation coefficient. So a residual is the difference between an actual y value and one predicted by the line of best fit. So, for example, if this is our data, so these green points are data, and the black line represent a line of best fit, notice we may have some points that are directly on the line, but usually there's this difference. And that difference is what we call a residual. So each of these points is going to have a residual value. How far away is it from the line of best fit? If it's above the line, it's going to have a positive residual, like this one down here. If it's below, it's going to have a negative residual value. And what we're going to be looking for is we're going to use those values to help us determine if our line is a good fit or how good of a fit it is. So obviously we want, like we talked about in the previous section, we kind of want there to be this balance of points below our line and points above our line. And we also want the residuals to be small, right? We want our line to be as close to as many points as possible. So that's kind of what we're going to be looking for. Our next idea is a correlation coefficient, and we use the letter R for this, and we'll see an example of this in a few minutes. This number, or this R value, is an indication of how well our line of best fit actually fits our data. And we'll talk more about that again in a minute. So let's jump right in and start looking at a problem. Example 1. We've seen this example in the past. We're just going to do something a little different with it now. If you want to maybe pause and take a minute to read this over, I will read it in just a second, but I'm going to go quickly, so it's going to be important that you understand what the example is talking about. So the table shows the total number in millions of subscriptions to a video sharing website, X years since 2010. So in other words, this would be the year 2010 because it's 0 years since 2010 and there were 9 million subscribers. In lesson 4.4, we use this table to create this equation, y equals 10x plus 6, to model the data. Use this equation to calculate residuals and determine if the model is a good fit. So if I'm going to use this to calculate the residuals, so residual, we calculate these residuals by taking the actual value, having trouble writing today, actual value minus the predicted. Okay, and the predicted value comes from our line of best fit. So here are our actual y values. We have an equation which we can use to find the predicted values. So our equation here is y equals 10x plus 6. And so what we're going to do then, I'm just going to kind of expand this table here. We've got our equation, and then over here we're going to find our residuals. Okay, so this is our actual y value. To find the y value predicted by the equation, I'm just going to plug in my x and see what I get out for y. So in other words, when x is 0, I'm going to plug 0 in for x, and I'm going to solve for y. So this would be 10 times 0, which is 0, plus 6. So this first value would be a 6. In other words, if we're using this line to predict values of y, we would get 6. And we're just going to keep doing that. And these actually work out really pretty nicely because of this 10x. So when x is 1, we plug that in. We have 10 times 1 is 10, plus 6 is 16. I'm going to start moving pretty quickly here after this one. When x is 2, we have 10 times 2, which is 20, plus 6 is 26. So when x is 2, y is 26. And since our x values just increase by 1 every time, this works out really nicely. So we're going to end up with 36, 46, 56, and so on. 80, 86. So that's going to be the first step when you're trying to calculate residuals. Okay, you're going to need to find those, what we call the, this is what we call those predicted values, and then these are the actual y values, right? Actual comes from our data, predicted comes from our line of best fit. And then to get our residuals, we just subtract. Okay, as we said, actual minus predicted. So in this very top one, we would end up with 9 minus 6, which is 3. In the next one, we have 21 minus 16, which is 5. And I'm not going to write this out for everyone because I think you should see where this is going. I'm just subtracting across like this, actual minus predicted, actual minus predicted. And here are the values that you should get. 0, -3, -3, -3, 71 minus 66 is 5, 0, 3. So notice some of these are positive, some are negative. Like I mentioned when I showed you the graph, positive values are above the line of best fit. Negative values would represent points below the line of best fit. And so what we're looking for when we're trying to determine if the model is a good fit, we're looking for a couple things. Let me kind of write this over here. Model, let's say this, the model is a good fit if, I'm looking for two things. Number one, we have approximately the same number of positive and negative numbers. So about the same number of positive and negative numbers, because that means that our line is kind of running right down the middle of the data. If we have approximately the same number above the line as we do below, that's what's represented here by positive and negative numbers. The second thing we're looking for is that the residuals are relatively small. And relatively means like relative to the situation. If all of our original data were like really small, like 1.2, 1.3, if there's only a very small difference, then relatively small would be different than if we have really big numbers. So if we look at our data, let's look at first positive and negative. I've got 1, 2, 3, 4 positive numbers, 1, 2, 3 negative, and 2, 0. So yeah, I've got about the same number of positive and negative. Residuals are relatively small. So compared to our data here, are these numbers 3, 5, 0 relatively small? Yes. That means that they're fairly close to that line. Okay, so is our model a good fit? We would say, trying to figure out where to best write this. Yes, the model is a good fit. And then we will want to say something about how we know. We say residuals are evenly distributed, meaning that positive and negative and relatively small. Yes, it is a good fit because it fits these two things. Here we say the residuals are evenly distributed. That means I've got approximately an even positive number, a negative number, and the residuals are fairly small or relatively small. The other thing that we're doing in this section, again, you might want to pause and read through this example, and then we'll kind of talk through it. We saw this example again as well. Relationship between average daily temperatures and coats sold per day. We have our table of this data. We have our graph. Use technology to find an equation of the line. Round the slope to the nearest tenth, the y-intercept to the nearest integer. Identify the correlation coefficient and round to the nearest hundredth. Okay, so we need to find these values, which we can do by just punching our data into Desmos. And then we can round off our values and interpret the correlation coefficient. It is going to ask us to round this similar way in our practice, so make sure that we're kind of paying attention to this rounding. Okay, so here's kind of a little note on rounding down here. If we have this number, integer is any whole number. So if I was rounding this to the nearest integer, that would round up to 3, because I have to look at the integer and then I have to look at the number after it. This is a 7, so this would get rounded up to 3. Okay, if it's 5 or above, you round it up, if the following number. Rounding to the nearest tenth is 1 decimal place. Rounding to the nearest hundredth is the 2nd decimal place, and then this would be the nearest thousandth. If we were rounding to the nearest tenth, this would stay exactly what it is, because the number after it is a 1. If I was rounding to the nearest hundredth, this would get rounded to 2.72, because the number after that is a 5, so the 1 would get bumped up to a 2. So if we punch this into Desmos, which I've already done, this is what you should get. When you punch this into Desmos, there's a little button up here on the left, kind of where I've just highlighted here. It's gone now because I already did it to create the linear regression. I wonder if I can, there you go, I can X that out. So now if I push this button up here, it'll create the linear regression, and it will give me an equation down here. And we also have a R value. So we're looking down in the bottom left-hand corner. We have the equation y equals negative 1.303x plus 104.8. See if I can remember that to copy it down. 103.3. I think that was right. Negative 3.03 x plus 104.8. And then our R value was negative 0.9335. So here's what I'm looking for. These are my equation and my R value. So it tells us to round the slope to the nearest tenth. So this is our slope to the nearest tenth, and the y-intercept to the nearest integer. So I'm going to drop that 0.8, but it needs to get rounded up to 105, since that is 5 or above. So the equation we want to use, and if you were plugging this in on your practice, you would have to enter it this way or it would be marked wrong. Negative 1.3x plus 105. So from there, we can take away a few things. Again, we know our slope is negative 1.3. So it might ask us to like interpret that slope, which we've done in the past. Our y-intercept is 105. Our R value, it asks us to round this to the nearest, rounded to the nearest hundredth. So 2 decimal places, and since it's a 3 after that, it's just going to stay negative 0.93. All right, so I've got our original values up top, but these are the ones that we're going to use because they've been rounded the way we were asked to round them. So let me go back to the question. Okay, we've got a lot of information here in front of us. Let's see what the actual question was. I found the equation for the line of best fit. We've done our rounding. Interpret the correlation coefficient. So all it's asking us to do is find this and round it, which we did. Find the correlation coefficient, which is our R value, and interpret this value, meaning say what this means. So the correlation coefficient is always a number between -1 and +1. Okay? So it sits somewhere on this scale between -1 and +1. So if this is -1, we've got 0 kind of in the middle, and then this is +1. And so based on this value, we can determine whether or not something has a strong or a weak correlation, and whether or not that correlation is positive or negative. So strong correlation means that it fits our line really well. Now let me just put a couple more. So this would be like -0.5. This would be +0.5. This is a pretty strong, or like it is close to -1. So that's kind of like over here on our little scale. This is a negative number, and it is very close to -1. We say this would be a strong negative correlation. If it's between -0.5 and 0, this is what we would call a weak negative correlation. And you can probably guess on the other side, this would be strong positive correlation. and this would be a weak positive correlation. So in other words, if we had a correlation coefficient up here near +1, that means our line fits our data really well. And then it's going like this, right? Positive correlations look like that. And if they're strong, that means that our data is nice and close to our line and it fits it very well. This zero correlation is where like our data is all kind of spread out. It doesn't even look like a line at all. And then strong negative is, again, like a negative slope. And our data fits that line really nicely, so it's all going to be really close to that line. So if we were to answer this question, interpret the correlation coefficient, we would want to say something like this. Since r equals negative 0.93, we have a strong negative correlation. And that's all you need to include. Is it weak or strong? Is it positive or negative?